Hello everyone, welcome to Meddesign Engineer X. I'm starting a new series today. It's called Medical Device Electrical Safety. We're just going to go over the hazards associated with using electrical when handling electrical medical devices in the workplace. If you're a biomedical engineer or clinical engineer, you may have already probably experienced some form of electrical shock. And if you don't know, electrical shock is basically just where electricity causes our body to experience pain or trauma. And if you're a clinical engineer working in hospitals, is a very important topic because, of course, part of our maintenance is doing electrical safety testing. It's literally our bread and butter when it comes into this field. And it's important to know just the hazards associated with it, which would really help us engineers when we're working in hospitals, in any sites that we're based in. Also, this is an important topic when we're going through interviews. It's normally a topic that normally goes 99% of the time. So there's different types of hazards associated with electrical shock. But first, let's discuss how an electrical shock actually happens. So when we receive an electrical shock, it actually affects a nervous system. And by nervous system, I mean it's a network of special cells in the body called nerve cells and neurons. And nerve cells communicate to each other by acting as transducers, which is just transferring energy from one form to another. So in this case, creating electrical signals in response to the input of certain chemical compounds called neurotransmitters. And then they release these neurotransmitters when stimulated by electrical signals. So one form of physiological effect of an electrical shock is tetanus. Tetanus is when our muscles, when they respond to an energized live conductor, we're unable to bend our fingers and we're unable to let go of the wire. How? Because the electrical current that's conducted through the person's arm, the bending muscles will win, and this clenches the finger into a fist. And of course, this is very dangerous because it only takes a small amount of electrical current to cause someone for heart failure. Another form of hazard of electrical shock is fire and explosions. So when you're servicing diaphragms or air blowers, when there's a buildup of heat and dissipation, this can cause fire, even explosions. So when you consider the use of electrical devices in hazardous environments, such as operating theaters, where gases and liquids are present, this can cause fire and excessive heat to build up, which could easily ignite in the presence of an electrical fault, at best causing fire or an explosion. Lastly is electromechanical devices. So hoists, beds, they all use mains and battery power to operate the motors inside them. So if there's a fault in the system and electronic circuitry, this could result in sudden movements of the bed. And if an engineer or a staff or a patient, is in close contact with these proximities, it could result in trapped fingers and injuries. And also with live parts like the rails, which sometimes are made of metals. Once again, this could cause an electrical shock, and again, fires, because there's greases as well used, and of course mattress and other padding on this type of devices. So today I just wanted to go over an overview of electrical safety, but in the following next episodes we'll go over the physiological effects. We'll go over that more, electrical current, classification of medical devices, and statutory documentations that's related to electrical safety, and of course testing of these medical devices. And lastly, we're probably gonna create a 7-part series, and we'll end it off with standards like the 60601 and 6353. And we're ending the first episode there. And thank you for watching, and we'll see you in the next episode.